4 point masses are fastened to the corners of a frame of negligible mass lying in the xy plane. Let W be the angular speed of the rotation. Then there are various statements which we have to verify. Okay. The first statement is rotational kinetic energy associated with the given angular speed depends on the axis of rotation. Yes, it is true. If I take the axis of rotation as y over here, the kinetic energy over here will be equal to half I omega square. This will remain constant. Now what is I over here? I will be equal to, since the small mass m are situated on the y axis, we will not consider that mass. I over here will be equal to m into a square. Okay, it will be equal to m into a square, and the similar mass is situated on the opposite side, plus m into a square into omega square. So basically it will be equal to m a square omega square. Okay, and if I take it along y, if I take the axis along the x axis, if I take the x axis over here, it will be equal to, similarly I will use the same formula. This is kinetic energy along the y axis, and the kinetic energy along the x axis will be equal to, over here it will be equal to, instead of capital M it will be equal to small m, and the perpendicular distance over here is equal to b, so small m b square omega square. Okay. So option number A is correct, that the rotational kinetic energy will depend on the angular speed of the body. Okay, will depends on the axis of rotation of the body. Okay, it depends on the axis of rotation of the body, because along y axis it is different and along the x axis it is different. Let us find out the second one. Rotational kinetic energy about the y axis is independent of the m, and its value is equal to capital M a square omega square, which is correct. Okay, since there is no factor of small m, I can say that the kinetic energy is independent of the small m. So option number B is also correct. Let us see option number C. The rotational kinetic energy about z axis depends on m, and its value is equal to m a square plus m b square into omega square. Let us take an axis which passes through the z, let us take an axis which is perpendicular to both of them, that is the z axis. So now the moment of inertia over here will be equal to half into, it will be equal to the summation of, it will be equal to, moment of inertia will be equal to summation of mi ri square, okay, into omega square. So basically it will be equal to half into, there will be 2, there will be equal to, it will be equal to m 2m into b square plus 2 capital M into a square into omega square, which will be equal to over here m b square plus m a square into omega square. So option number C is also correct. Let us find out the, let us check the option number D. Rotational kinetic energy about z axis is independent of m. No, it is contradicting our original statement C. Okay, it is contradicting our original statement C. So the correct answers are option number A, B and C.